Alrighty, folks, in this video, we're going to talk about simplifying pretty complicated expressions and also evaluating a function that is pretty complex as well. In this particular problem, I just want to point out some of the algebra that is allowed when you are dealing with simplifying these kinds of things. First of all, I have had some of you in your assignments looking at something like this and saying that you can cancel, please watch carefully, something like this with something like this. And that is absolutely not algebraically feasible. Okay, it is not allowed. I'm not going to go into all the detail of it, but you can only cancel factors from numerator to denominator. Alrighty, we do need to be very, very careful. So what I'd like to point out here is that I have a factor here of x plus 1. That's like a little package. Those guys are like married. I guess you could look at it like that. So that factor can only cancel with a like factor in the numerator. Now, some of you might be looking saying, whoa, there's an x plus 1 right here. That factor is not a complete factor. It is actually attached to this 2x squared. So you can't cancel this x plus 1 and this x plus 1 right here. Won't work because that's attached to here. All right, that x plus 1 as a factor, however, can cancel with this fully complete factor over here, that x plus 1. So if I were to rewrite this, I would get x minus 3 times 2x squared plus x plus 1. And incidentally, this trinomial right here is not factorable. Alrighty, over 2x. That is as far as I can go on this particular situation. I cannot simplify that any further right now. Okay, next up, whoops, let's go backwards, my apologies. Alrighty, we want to concentrate on evaluating. And so that little skill that we just talked about is going to help us as we are evaluating this complicated function, f of x minus 4. We're being evaluating f of x equals 3x squared minus 1 over 4x minus 8. And we want to substitute all of the x values for x minus 4. So let's go ahead and do that using proper function notation. F of x minus 4 equals x minus 4 is going to be substituted here for the x times x minus 4 squared minus 1. All right, take a note of how that happened. Over, now this x right here, of course, has to be substituted for x minus 4. So we get 4 times the quantity, x minus 4 minus 8. Now we can start to simplify this, and hopefully we can get to a point where we can maybe cancel some factors like we saw in the previous slide. So f of x minus 4 equals, and we do need to simplify this, and that is not x squared minus 16. We do need to recognize that that is x minus 4 times x minus 4. All right, and we have to use that FOIL method. So we end up with x squared minus 8x plus 16 when you FOIL that out. So let's substitute that and rewrite it. 3 times x squared minus 8x plus 16. And that minus 1, she's still tagging along here. We'll deal with her later. Okay, times, I'm going to distribute the 4 to my x and my negative 4. So I get 4x minus 16 minus 8. Okay, continuing to simplify, I'm going to distribute my 3. Order of operations is so very important here, so please pay attention to kind of the order. Order is important, it does matter. Equals 3x squared when I distribute minus 24x plus 48 minus 1. That minus 1 is still hanging out there. Okay, and then down here, I do have some like terms I can combine here. I get 4x minus 24. All right, keep on keeping on. F of x minus 4 equals 3x squared minus 24x. This simplifies to plus 47 over 4x minus 24. Now, at this point, we have to look at whether or not this numerator is actually factorable. Okay, if it's factorable, we might end up, just like we did on this previous slide, with some individual binomials that might be cancelable with something in the denominator. However, in looking at this end result, I know that 47 is a prime number, so it's probably not factorable, okay? And there's no way to put 47 and 3, and I mean, you're just not going to be able to factor that. I could factor out a 4 down here, but that's not going to help us either. So this actually is my final answer. Okay, I am seeing some of you in your assignments try to do things like, this is not correct, cancel this minus 24 with this minus 24. Can't do that. Okay, this is considered a factor. Okay, this is a factor right now, and I could, like I said, I could rewrite it as 4 times x minus 6, but still there's no x minus 6 floating around up here as a separate factor that I could cancel that guy and cancel that guy. So this is it. We can't simplify this any further. Please pay attention to that as you move forward in working with these problems. And talking with Mr. Vahill, he has said that the biggest obstacle to calculus isn't the calculus, it's the algebra. Okay, so this stuff's important.